Our topic today, I think you know all who are we, because who we are, because all speakers have been introduced, and now you are turning to be a panelist. I don't understand what did you have done. I was also in the bar, but I'm rather okay. I don't know what did you drink. Okay, so our topic is global technology trend in maritime equipment. This has been started by Mr. KS Ree, SK Ree, sorry, from Hyundai, HD Hyundai Heavy Industry. He presented, let's say, a kind of a generic methodology for the multi-fuel engines. And starting from him, I would give one question to each panel. So you're gonna, let's say, answer this, and then I will turn to the platform, to the audience, and then audience, you may raise your hand if you have any question or comment, or you disagree anything. Yeah. Okay. So my question goes to the how is the HHI ensuring its new multi-fuel engines stay flexible and safe as shipbuilding shift from LNG to zero carbon fuels like ammonia and hydrogen?
Yes, this question is handed over to me this morning, but it's not easy to answer these questions. So even though that I trying to prepare the answers, yes, we are consistently developing various type of fueled engines, um, like is LNG, is methanol, is ammonia, and even the hydrogens, which are based on the design and technologies already proven on diesel engines through the long period. This means the maximum compatibility of parts between the different fuel engines will allow the modification to use the different fuels to minimum extent. So, as you know well, the alternative fuels have its unique toxic characteristics. Therefore, the various and the special safety design are applied to source blocking fuels exposed to humans. So, I've already mentioned on my presentations a double wall piping systems adapted inside the engine room as well as the engine itself. And common rail system, yeah, the for methanol and ammonia. And diesel cycle combustion system for reducing significantly gaseous fuel slip. And automatic fuels purging system with inert gas just after gas trip or engine stop. The special sealing system for each fuel characteristics and extras. In parallel, we are working with these global partners and some classes to come up with the guidelines and regulations on safeties. Yeah, that's all.
Okay, thank you very much. Then can you understand, or your, let's say, strategy to the market is multi-fuel engine, yeah? Whatever fuel comes, you are ready to accommodate, yeah? Okay, good. Thank you. Wonderful. Okay. And you presented a remarkable technology, yeah? This silicon coating reduces the greenhouse gas significantly. That's good. And also, you also combine this digital technologies, so you will gain lots of digital data and also life cycle monitoring. And okay, this is of course to prove your Hempel goal to verify CO2 reduction. But what will you do? All those data, you know?
Great question, because I didn't cover it during the presentation. So as we mentioned, we're able to monitor and understand how much carbon dioxide we save through our coating system. So we have a system called SHAPE. So you may say, what is SHAPE? So SHAPE is a monitoring platform that we have within Hempel, which is used with our customers, but we also monitor globally the vessels in the environment, as you can understand. And it's a system which gathers, collects information and analyzes it. So what does it analyze? The in-service performance. There's lots of components, obviously, the GHG emissions, the fuel consumption of the vessel, the environment it's in. So there's a nice big algorithm in the back end, as you can understand, which filters all this information and then understands how we have successfully both provided the performance and the efficiency, but also helped towards driving down the carbon dioxide. So it's a tool which our customers have connected to, and we have this information. But if there's anyone around that is looking into the Hempel coating system or would like to try it for purposes, we can connect to give you more information of how this mechanism works to provide the information needed. Thank you.
Excellent. Thank you very much. Thank you. Next goes to Senda. Yeah, I would like to ask you what power management or storage innovations are most improving the efficiency and reliability in hybrid and let's say electric vessel today. And and also I have two questions actually, because there is no free. You asked everybody hands up, so you got the free photo. So, and you said your company is prepared the spare part all over the world. This spare part. What do you mean? This means a complete piping?
Yeah, thanks for these two interesting questions. And thanks for giving me the second one, because the first one is a bit further away from my knowledge. However, let me quickly answer that one as well. Electrical vessels or hybrid vessels, obviously what we really need then are batteries, long-lasting batteries. We all know that vessels go from A to B or to C or to D or to E, wherever it goes, and it can be long trips, especially now when Suez, for example, is a difficult region to get through. So they need to go all the way over South Africa. So long-lasting batteries are very important. And now grabbing back to more the LNG business, where we are very well located in, I would say hybrid systems, and then, for example, a battery system, electrical system with a good battery combining with a LNG system to optimize, distances. So to optimize long-lasting periods where the vessel needs to sail over the oceans, that would definitely help. So definitely hybrid system, but also, for example, LNG, but you could also think about the other fuels like ammonia or hydrogen, a combination of that to have something alternative when you need, in peak usage. So I think that is one thing. And then secondly, the spare parts. What I actually mean to say there is systems need maintenance. Systems on board of vessels need maintenance. And obviously, when there is a good spare part management behind, we as a manufacturer should know what an operator, the crew on board, needs in the coming 5 or maybe 10 years. In order to manage that, we think it's our responsibility to optimize the spare part availability in the different areas in the world where vessels operations are taking place. So by doing that, you limited downtime of a vessel. So if you need to repair something, you need to replace something, the spare should be there already available. But secondly, again, you can transfer from a factory towards a storage location, spare parts, in one go, and you don't need to send out spare parts all around the world thinking about our footprint, which will cost a lot more create a lot more, CO2 emissions, for example, because you need to fly them over and et cetera, et cetera. So, yeah, that's what I mean to say with the spare part management.
Thank you very much. I'd like to spot to give a supplementary background for the first question. I think this is the question about in case of hybrid or electrical vessels, then obviously the system will be different. So what is your, let's say, prediction about LNG storage system and its innovation? I think that's the meaning behind.
Well, yeah, it's again, it's a bit far away from my bet.
Yeah.
So a bit complicated to answer. I'm not sure if there are in the audience people who can
Yeah.
answer this
Okay.
easier than I, because again, yeah, it's far away from my bet.
All right. So then we can address this question to the LNG specialist. I'm sure there is enough number of the companies in the booth, Hall A, I think. Is it Hall A? Okay. Hall 1, I'm sorry, Hall 1. Okay, so thank you. Thank you, Sander. And then my question goes to the Stian. And thank you very much, Long Way. I think you are you took the longest way from Norway all the way to Busan, yeah. Okay, so you presented this remarkable system and also actually onboard experience of carbon capture. And the question is, what key lessons from the Clipper Erics CCS onboard project will shape wider rollout, especially around the CO2 handling and energy use?
Thank you, KK. These are interesting questions. I would like to add we are still learning from this pilot installation. This vessel started sailing in February this year, and she's still, let's say, equipped with our technical experts to wrap up and pull out all the secrets from the system. CO2 handling wise, I think that's really that's really a key takeaway. This needs to be developed because obviously this is the first thing every stakeholder asks: what to do with the captured CO2. The technical handling is not a challenge, and there are, as I mentioned in my presentation, there are reception facilities. They are very narrow at the moment. We need this value chain to open up and develop, and I'm sure that only happens through pilots like we are doing, or like these pilot customers of ours are doing. So they are paving the way. As for the energy question, it's clearly, when I say that we have designed, well, on a technical basis, the capture rate of CO2 is a balance between energy consumption and capture rate. So you can easily capture more than we do, but we are trying to find the sweet spot so that in an elegant way you can use available waste heat. Sorry, I need to hit the bar afterwards to fix my throat.
Okay.
Because then your only energy penalty is going to be the extra electricity you need to run the system.
Okay, thank you. And you said 5 tons a day is your capture rate at the moment?
50.
50.
5-0.
Then when the ship goes 1 week, then 350 tons.
That is correct.
Then the receiving terminal is to be prepared for those, yeah? Because 350 tons of the CO2 is not small, yeah?
It's not small, but it is small, and all ships are going to be small point sources if you compare to land-based major emitters like coal-fired power plant. that is going to be a huge amount of CO2.
Yeah, yeah, okay. Thank you for your honest answer. Thank you. Okay, so my last question goes to Michael. Thank you very much. Your milestone of your career, that was very impressive. And you have well connected to the theme of icebreaker. And how can a Korean shipyard move to, this is a kind of sentiment. I know this is a little bit sensitive, but I must tell. Most of the Koreans or many others as well, in terms of when you're talking about especially geopolitics in U.S., then we feel very much like a kind of oppressed as act as a subcontractor rather than partner. So what is, because you have such a great experience, so what is your, let's say, opinion and also your, let's say, advice, how we can turn from the subcontractor to be a partner?
Okay, 감사합니다. I'll do this one in Korean. 그 한국 조선업하고 이제 그 관련된 협력사들 일단 이거 판을 잘 이해해야 돼요. 잘 판을 이해하면서 이 미국에서도 활동할 수 있게 자동차 업과 비슷하게 일단 미리 2-3년 전 리타임에서 갖고 거기 이제 일단 비자 가진 분들부터 좀 마련하고 거기 그 로컬 팀들도 모집하고 거기에 이제 그 환경에 하나가 돼야 되는 거죠. 그러니까 우리가 남이 가는 것이 아니고 거기에 그 있는 회사고 그 딴 기업들만큼 로컬 플레이어로 인정할 수 있게 그것을 우리가 M&A로 할 수도 있고 아니면 설립으로도 가능한데 한국에서 우리 아저씨들 50명 보내서 해결할 문제가 아니에요. 거기서 이제 사람을 모집해야 되고 커뮤니티에도 이제 이것을 그 관계를 가져야 되는데 예를 들어서 제가 그 STX 떠나서 그 세아 옛 부산 파이브에 있었거든요. 그때 그 휴스턴에서 그 철강 공장을 3개 샀습니다. 트럼프 1 때 원래 주인들이 러시안들이라서 이제 얘네들은 빠져야 되니까 우리가 이걸 인수하면서 뭐 그 동네 축구 시합부터 PTA 뭐 이런 활동들을 많이 할 수밖에 없는 것이 그 제한적인 그 인원으로 거기서 로컬이 고용하고 활동하려면은 이런 커뮤니티 플레이가 좀 상당히 필요 있습니다. 그래서 우리가 이제 일단 몇 가지 더 있는데 그 PR도 옛날에는 뭐 피할 거 피하고 알릴 거 알리고 이런 방식으로 아니고 리스닝 그러니까 남들이 그 시장에서 알려주는 것을 잘 듣고 인텔리전스 모집을 해야 되잖아요. 최근에 그 조지아에서 그 현대 플랜트도 2년 전에 LG가 같은 문제가 있었고 우리가 충분히 워닝이 있었거든요. 그걸 이제 협력사들 하청업으로 리스크를 밀었던 거죠. 본사 직원이 걸린 사람들은 거의 없을 겁니다. 왜냐하면 자기들은 비자가 다 있으니까. 근데 여기서 조선소도 상당히 보수적인 업계에서 옛부터 협력사들 하청업에 이런 리스크하고 부담을 줬던 것을 외국에 가서 그렇게 활동하면은 큰일 난다는 거죠. 그래서 그런 거부터 준비를 해야 되고 그리고 서브컨트랙터가 안 되려 그러면 기술 개발을 해야 되는 거고 좀 전에 말씀드린 것처럼 그냥 도장 찍기처럼 그 패턴트 추진하는 것보다 이거 옛날에 좀 많이 그랬거든요. 가치 있는 거래 가능한 지식재산 이것이 이제 상당히 중요하고 정부 지원도 그런 것을 같이 학교에서 해야지. 저 학교에도 오래 있었지만 학교에서는 아시다시피 뭐 교수 연구 뭐 여러 가지 이런 그 성과가 기업에 도움되는 성과가 아니거든요. 그래서 기업이 이것을 이제 좀 목소리 내고 리딩을 해야 될 거라고 생각합니다.
감사합니다. Thank you very much. So now I like to have your questions from the floor. Okay, there's one.
I have one question to Sander. I'm afraid it's kind of a sensitive question. I heard that recently you stopped all developing activities on liquid hydrogen transfer. If it is true, could you tell us what was the major reason? Otherwise, do you have any plan for some increasing the R&D activities for liquid hydrogen transfer systems?
Thank you for the question. and not really sensitive. We are still developing liquid hydrogen transfer systems, although having said that, it's subsidized by European Union, and there is a certain reach in what is possible with these kind of subsidizings. And as a part of the development, it is still ongoing, but we have finally reached the end of that program. And we are a manufacturer, and we want to manufacture stuff. I mean, hoses or transfer systems and so on. But in order to do that, there needs to be an industry. And at this moment, for liquid hydrogen, and then looking into the marine industry, it's lacking. There is no real industry. And the only pilot project which has been done over the past few years maybe was between Japan and Australia with a liquid hydrogen bunker vessel. And that's been stopped. And that is a message. Maybe not a good message, but it is a message. It's not up to me to say good or bad, but it's a message. And for us as a manufacturer, we are in need of an existing industry. So we did not quit our development. We are still ongoing with that, but it's on a very low fire at the moment. It's slowly boiling, nothing more than that.
Thank you. Is there any other questions?
I would like to catch Mr. Stian. Congratulations on your innovative carbon capture technologies. I would like to know the cost, CapEx and plus OpEx to benefit of ship owners. Now you are trial on board carbon capture technology. How about your opinion? OpEx and CapEx to benefit from owner side.
Well, it's a crucial question. I hope you understand. I can't really go into details for two reasons. First of all, we are in the pilot stage. Pilots are more expensive than a serial production. So from the CapEx cost level we are at today, it's reasonable to expect that the CapEx will go down over the next few years. Also, the competition will develop, also reducing the CapEx or the cost for the ship owner. It is, if you look at it from a technical point of view, a CCS system like we produce is basically another scrubber system. You have a scrubber system to reduce SOx, and you can use the same scrubber with a different liquid to capture CO2. So having said that, that's the starting point, a scrubber system, but then comes a lot more added paraphernalia, if you will. So it will be quite a bit more expensive than a scrubber system.
Yeah.
That's the CapEx. I could mention that also this pilot system, the Clipper Aries that you saw the pictures, that one received 7 million euros in funding from the Norwegian government. So having said that, the CapEx and the installation is obviously more than 7 million euros for this vessel. The OpEx is not very high. That's I wouldn't say insignificant, but there are no consumables here other than you need to, the electricity we have already mentioned. You have a plus minus 10% penalty in fuel. That's an OpEx. The other OpEx is at some frequency you have to replace your your solvent, the liquid that is capturing the CO2. We don't know yet how frequent you have to do that, but that's very insignificant in the big picture. That part of the OpEx.
Yeah, thank you.
Here.
The next questions. How about your ideas to install your technology about carbon capture? In case of big container, 13,000 TU class or more than, how about your ideas to install your technology on board a ship actually in near future? Is it realistic or?
It's indeed realistic, and we have a lot of interest from the container segment. We have done some feasibility studies. The biggest challenge is the same thing for this tanker you just saw, is going to be the tank capacity. We have two different concepts. One concept is where you, on a container vessel, you use ISO tanks to store the captured CO2. That will fit right into the stack on the container vessel, and you can lift them off, and you can lift on board empty ones. But you have to give up container space, that's for sure. But then again, if you are going to install methanol or ammonia, you have to put on a lot of additional tank space. So all the decarbonization measures will be demanding from a space perspective. There's another difference I also mentioned briefly. If it's a new build, you can consider structural hull tanks. That's going to be a big change from a retrofit where you have to use sea tanks in some way or another.
Thank you very much.
Thank you. Thank you very much. I have a very quick question from my curiosity, Anna. Do you have any competitor? That means, are there any technology similar to yours?
Yes, obviously. Through the years, there have been competitors coming out with silicons. So it is a competitive market. But I think due to the fact that we've been around for many years and have our data, we can prove to why we mention and have the conversation on the vessel type and also its operational drive. So we have the specs to make sure that the efficiency is driven on the vessel.
Okay. Yeah, that means the effect or the efficiency is proven, yeah?
Yes,
Thank
correct.
you. Thank you very much. Okay, I can accept only one short question. Is there any? Otherwise, I would like wrap up. So under the title of Global Technology Trend in Maritime Equipment, we have 5 presentations. So Mr. Sang-Gi Lee from Hyundai presented the green multi-fuel engines. So you heard about all, let's say, methodologies to fit or to comply any fuel. And then Anna, you presented this impressive technology about the silicon coating. And Sander, yeah, I'm interested about your way of presentation. I have learned that. So you presented about, let's say, more potentials about LNG, I say. Is it really transient fuel? I think that's a very good question, yeah. And then Stian, it's also a very good lesson you brought us, this carbon capture technology on board. And also, Michael, it's a very good introduction about your life milestone in relation to this Hope Maritime and also Icebreaker. Thank you very much. So I hope, dear audience, you learned a lot today, and you can now feel what is the technology trend over the maritime industry. So I very much like to sum up and thank you very much. This is the end of the session 5. Thank you, Kelly.